Hi viewers, this is Sri Ramalu. So today's topic is Bloch theorem. Bloch is the name of the scientist. So first statement. So dear friends, this is a important one, and you cannot find any textbooks. So mostly I referred a lot of books and I gathered it. So please prepare well for for this Bloch theorem. And now statement. What is a statement? For what we apply this Bloch theorem. The solution of Schrodinger equation for a periodic potential must be of the form psi k of r is equals to uk of r into e power of I k dot r. So this is the Bloch function. Okay, but Bloch function is mostly we use to solve the Schrodinger wave equations only. Okay, so we use to solve Schrodinger wave equation, and that must be the form uk of r is equals to psi k of r is equals to uk of r e power of I k dot r, where r is a position vector. And here uk of r has the period of the crystal lattice, and with uk of r is equals to uk of r plus t, where t is a crystal translational vector. So sometime we write it is a capital R also. For what? T, in the place of t also we can write capital R also. Next explanation. The eigenfunctions of the wave equation for periodic potentials are the product of plane wave e power I k dot r in equation 1 is called Bloch function. So here the plane wave function, so uk of r is the plane wave function. It is multiplied with this, then we can get a Bloch function, that is psi k of r. K means the value, that is we can write there 0 1 2 3 so on like this. We assume that uk of r is non-degenerate. Degenerate means equal energies, non-degenerate means not equal energies. Consider n identical lattice points on a ring of length L, length na. Here identical points we have to consider. Why? Because we apply it to the crystals, so that is why crystal has identical lattice points, so that is why identical lattice points are given here. And let there are the n number of lattice points are there like this. N number of lattice points are arranged at equal distance. The gap between any two values, any two lattice point is how much a that is. See here, it is one lattice point, another lattice point, like this. How many? This side and this side we have a lot of values. And let at this point wave function is the psi of x. Why? Because it is along x direction, and here distance is a. When we move from this lattice point to this lattice point, what happens? Psi of x plus a we get, and psi of x plus a can also be written as psi of x always. And in terms of potential energy also, u of x can be written as, suppose here the potential energy is u of x. At this point how much it is u of x plus yes a. Yes, why it is yes? Yes means the number starts from 0 1 2 3 so on like this. So yes, if you write here 1a 2a 3a, then so first lattice point, second lattice point, third lattice point, like this it denotes. So all those things are given here. The potential energy is a periodic in a with u of x is equals to u of x plus sa. So here what? U of x is equals to u of x plus sa. Yes, a, if it is not sa, let it suppose if it is not yes, u of x is equals to u of x plus 0. Next, u of x plus a, second point, u of x plus 2a, like this, u of x plus 3a, like this we write. So instead of 3a, 4a, 5a, we write simply sa. Okay, here it is like this, sa is written. S is integer. The ring has symmetric. We look for solution of the wave equation such that psi of x plus a is equals to c into psi of x. Let what here ring I am saying, like this lattice points are there. If you move in this direction up to what distance? Infinity distance, and bend all those lattice points like this in the form of ring, then what happens? Again we come at the initial position only. So that is why psi of x plus a also written as c into psi of x. Again we come to the its an initial position only when we consider it like a ring. Okay, all the lattice points are arranged on ring. Here c is a constant, then on going ones around the ring. So when we move on the ring, so c is what? It is a constant. It has some value also. Okay. Psi of x plus na. Okay. So the distance between each lattice point is how much? A. Then how many lattice points are there? N. So total length is how much? Na. So that is na. Is equals to psi of x. Okay. Is equals to, why it is c power of n, you know? So psi of x for one lattice point. So for one lattice point, how we write? So it is a psi of x only. Psi star. For two lattice points, psi star into psi. For three last psi star, like this we write. Psi star into psi, we write sometimes psi square. So like this we get here c square. Here one thing you have to remember, psi of x is equals to generally psi star into psi we write. Okay, for two, one is a complex, other one is a normal, and here one is there. So this one is a constant. This constant can be written with a c also. Okay, so like this we write c, psi star of psi. Okay. For n number of are there, then we write simply c power n. So that is why here c power n psi of x. Here psi of x must be what? A single value. So we know the properties of wave function. Wave function psi must be single value and continuous, and it is a periodic. So one of them is here single value. Here the c. So c is one of the n root of unity. C is written like this. Okay, so c is equals to 2 pi I into 2 pi s by n. If you substitute n value and s value, you can get c value directly 1 only. Unity it is. Unity means 1. C value is unity always. Suppose uk of x has periodicity a, so that uk of x is equals to uk of x plus a. Okay, so at what, at next point it is a denoting. Okay, so then now see here what. So it is a plane wave function. Already second equation is there. What, see the second equation, c into psi of x. Okay, c term already we got. How much we got? C term is this much of we got. Okay, right? And psi of x term is what? Psi of x term is c into psi of x. Okay, psi of x is equals to c into u of x. Generally psi of x is c into u of x. So psi of x equals to uk of x into u power of this one. So this is the what it is, and here 2 pi s by na, 2 pi s by na, take it as k, then simply we write what? E power I k x. It is similar to the formula I k dot r. R in 3 dimension, it is in 1 dimension. Okay, so like this equation k is equals to satisfy the equation 2. So that equation 2 is what? Here it is the equation 2, it satisfies. So then the above theorem is proved. So like this we prove, and it is a equal formula, and we do not write like this. So we have to write like this also. Psi of x is equals to uk of x is into e power I k x y, k in the place of this value, substitute the k. Okay friends, thank you.